All right, well, thank you so much for the opportunity to start things off this morning. I'm excited about the workshop today. As you may have noticed, I'm not Kate Simonen. She was originally on this agenda. We work together really closely at the Carbon Leadership Forum, so I'm excited to share our research today. And so I joined the Carbon Leadership Forum at the University of Washington last fall to join our policy work. To lead our policy research. Previous to that, I was an architect and also launched a supply chain sustainability program for a corporate supply chain sustainability program. So we're excited to bring that. We're looking at this really from a lot of different perspectives. So Carbon Leadership Forum, we foster research, we incubate initiatives, create resources, and foster a network of over 5,000 architects, engineers, contractors, manufacturers, really everyone across the built environment space. And our mission is to accelerate the transformation of the building sector to radically reduce embodied carbon in building materials and construction through collective action. And increasingly, that relies on looking at what effective policies that align with our emissions and how to really get there, or how to create those policies. So starting out, since I'm going to talk about embodied carbon a lot, just making sure we're on the same page about what that means. Embodied carbon refers to the greenhouse gas emissions arising from the manufacturing, transportation, installation, maintenance, and disposal of building materials. In contrast to operational carbon, which is what we think about when we're running the materials, keeping the lights, or running the building, keeping the lights on. And specifically, we often talk about upfront embodied carbon here in the product stage. So thinking about material extraction and manufacturing, transportation from extraction to manufacturing. But there's also opportunities across the building life cycle. And so today I'm going to talk a little bit, some just about the product stage and some about the entire building life cycle stage. So including construction as well as maintenance and repair during the use of a building, and then really importantly, the end of life opportunities, whether that's deconstruction and demolition or waste processing. So that's where we can harvest building materials from existing buildings or reprocess them into new materials possibly. You are all probably very familiar with this pie chart, looking at really the significant impact that building materials have. In terms of global energy-related carbon emissions, building materials are responsible for at least 11%. And I say at least because that's really just looking at cement and steel and aluminum. That data is from the International Energy Agency. But one of the things that I like about this pie chart is that it shows how building materials are at the intersection of industrial emissions and building sector emissions. And these are both really difficult to abate emission sectors, industry in particular. And so it's one of the reasons that I think our work is really exciting, because there's a lot to be done, but a lot of opportunity. And steel and cement are the two largest emitters in the industrial sector and are obviously key building materials. And so those are two of the many large opportunities we have in this sector. Another key piece of embodied carbon is that it's right now missing from global climate policy largely. And what I mean by that is that because the majority of a product's embodied carbon footprint is generated across its supply chain, which is often global, the way that we do greenhouse gas emissions accounting, there's a lot of sort of finger pointing, and everyone is saying that someone else should be accounting for this carbon. So whether you're a company or a city or a country, you're looking at the emissions that are within your geographic borders. And so if the supply chain emissions are generated outside of those borders, then we're not accounting for them. And that means that if we're looking at policies that are only aimed just at, at the facility level, then we're going to miss a lot of opportunity to reduce emissions that are related to materials. And so one thing we've been looking at is what are the opportunities for policies that are at that product level where something is being used, because there's really a much broader range of strategies that are available there for reducing embodied carbon. So diving in a little bit about what those strategies are, we think of them really across, they sort of align with the way that buildings are designed and eventually the materials are selected for buildings. So before you've started to design a building, when you're just thinking about the project, that's really when there's the largest opportunity for reusing materials and buildings. And so either adaptive reuse of entire buildings or salvaging specific materials, designing smaller footprint, designing for disassembly, to reuse those materials later in life. As you are getting further into the design of the building, this is when architects, engineers, and others on the design team can really step up, and you can look at material efficiency, look at the shape of the building, as well as choosing between different different sort of systems, whether that's a structural system or a building envelope. This is where you can think about things like, should this building structural system should it be concrete? Should it be mass timber? Should it be concrete? Should it be steel? Those sort of high level decisions can be made at this stage with tools like whole building lifecycle assessment. And then the procurement stage, this is when you've already decided what materials you're going to use. And then there's a different suite of tools available for that stage. So that the question is not, should I use concrete or should I use steel? The question is, what is the best possible concrete available that meets my performance specifications? This is a really important distinction because depending on what stage you are at, there are different tools available for you to understand what solutions are possible. And as you can see here at the bottom, I've sort of highlighted that for each of these stages, there are different tools and policies. So for, at this early stage, it is more sort of rules of thumb. And then there's also building reuse and waste policies. This is most often seen in cities. At the system level, whole building lifecycle assessment tools are available. And this is anything from a fancy spreadsheet to really sophisticated tools that are integrated into building information modeling software and used every day in a growing number of architecture firms and engineering firms around the world. They've also been integrated into performance-based policies we see in zoning. There's a growing ask for these to be in building codes, and they're also already in green building certifications. And then last, in terms of procurement, this is where the sort of buy clean policies come in. And I'm going to talk about these two a little bit more. So what we're really excited about is performance-based technology agnostic policy solutions that are encouraging this suite of strategies. And so the reason I'm highlighting these two approaches, they're both necessary and complementary, and they sort of activate different kinds of solutions. So from the building approach, you're using whole building LCA to measure performance, to drive that sort of what is the number that you need to be below that can continually improve from. And this incentivizes architects and engineers to design a lower carbon building. So this really encourages the use of newer innovative materials. It encourages building material reuse. It's the world of strategies that sort of happen when you're still making decisions about what the building, how it's going to come together, how it's shaped, how efficient you can be with your structural system, a whole range of solutions. The material approach is also really important though, because it can incentivize manufacturers to invest in clean manufacturing practices, because it's saying, what is the best possible steel that I can buy? And the tool we have for that is called Environmental Product Declaration. And this can be used to measure the performance of a specific product, of a specific supply chain. And as I said, so this is key for low carbon technology adoption, particularly for products that can't really be easily replaced just because their performance function is so specific and unique. That may not always be the case, but with current technology available, that is available, and also they're a great solution for transportation and infrastructure policy. And just to say a little bit more about what an EPD is, if you're not familiar, essentially it's like it's often referred to as a nutrition label for building materials. Although a better metaphor might be the mileage per gallon rating on a car. It's directionally accurate. It's good enough to create policy around and to compare equivalent products. Is it absolutely perfect and exactly, how your car performs every day? No, that depends on the user. But it is close enough to be able to make key decisions about comparing products when in the right, if you're comparing functionally equivalent products. And that latter category, the material approach, is what we're seeing growing really quickly right now in policy in the US. So there's a federal program that's been proposed, the Clean Futures Act. There was a similar act proposed previous to that in the Senate. There are 6 bills introduced in 2021 in Washington, Minnesota, Oregon, New York, New Jersey, and most recently Connecticut. There is and some are buy clean, and then some are focused specifically on low carbon concrete. California passed a buy clean bill in 2017 and just recently published the first global warming potential limits for the materials that were included in that bill. So that was for steel insulation or mineral fiber or insulation and glass. And then we see a huge range of local action. I highlighted a few. So climate action plans, procurement requirements and incentives, some building codes. And a lot of these are building off of private sector leadership that has looked at similar policies. And then I wanted to make sure, given the name of this, to really talk a little bit about some of the alternative material solutions that we're seeing. So, I talked a lot about how these can be incentivized to be actually used in the building industry, but what are we talking about here? And so I excluded the high temperature processes because as Ryan noted, and we were talking about this workshop, that's sort of a separate conversation. But there are 3 areas we'll sort of highlight what we're seeing right now in terms of developing alternative materials for buildings. So one is lower carbon materials. There's a lot of solutions available today. The reduction potential from a sort of baseline of today practice is somewhere between 10 to 40% in that range, not as high as you'll see in others. But they fit really well into existing sort of supply chains and processes, but they also might be a short-term solution. So examples being products with high recycled content, cement alternatives like fly ash and slag, waste products that can be used as alternatives to cement for part of the cement needed for concrete. To other alternative cements, so limestone, calcined clay cement, which is that's where can get closer to the 40% reduction, Portland limestone cement. So these are they're replacing part of the material, but it's essentially, no one's gonna look at that product and know that it's any different than what they would be used to seeing. The second group, carbon storing materials, which are mostly bio-based materials, but not exclusively. And these are also available today. And they have the potential to be carbon negative. So, in theory, more than 100% reduction potential going into actually storing carbon. And I'd say that the research on exactly how much carbon is being stored, that is still developing. But a lot of these are materials that have been around for, hundreds or 1,000 years when it comes to rammed earth. This is really old technology. Obviously, we've been using wood for a long time. The question is, what is the best way to harvest that wood? But so examples being sustainably harvested timber, like CLT, glulam, non-timber structural cladding, so bamboo and other non-timber products, bio-based products like fiberboard and cellulose, straw, hempcrete, and rammed earth, so soil-based products. And again, a lot of these are sort of already available at Home Depot. These are things that you can use. It's just maybe they're not combined in the way that industry is used to seeing them, or there might be one piece that sort of needs to be overcome in order for them to be used more broadly. So, maybe there's not a perfect waterproofing solution yet, or maybe it's not clear whether they can be used for certain building types because of fireproof. But it's sort of one aspect of them needs to be updated, but it's not creating a whole new material. These already exist. And then the third category is more the emerging materials, where these tend to be a little sexier. They're still in development. And some examples there. So carbon storing aggregate, so synthetic limestone aggregate from sequestered carbon dioxide. There's algae and seaweed products, mycelium, which is basically mushroom spores growing insulation. And so there's this whole range of other emerging materials, and we don't really know what the reduction potential is because they're not market ready yet. So we don't have case studies of sort of what that possibility is. And just to provide some sort of photos to illustrate that last category, so I already talked about these. It's sort of fiber, earth-based, purpose-grown, or waste stream materials. So, and I think just also highlighting there, these are exciting because they have the potential to not just store carbon, but also support rural communities where they're grown. And one of our partners that we research with often in this area is Endeavor Center. So just want to make sure I give a shout out to them because I'm sure these images are from slides we've had before.